All right, so in section 3.3a, we want to be able to identify zeros, and then we want to sketch graphs of polynomial functions. We need to kind of have an idea in our mind of what a couple things are going on here. There's a term called end behavior. It is either going up or down, on the ends. Now, what do I mean by the ends? I mean at the ends of the graph. Okay? So, for instance, the situations are both sides can go up, both sides can go down. The left is down, the right is up, the left is up, the right is down. Those are the four situations that we run into. There's only four of them. Now, let's just quickly draw a few of these. We know what they look like. Y equals x. It's a line with a slope of 1 going through the origin. This is obviously up on the right, and I'm going to be using REB for right end behavior, LEB for left end behavior. Well, if it was negative odd, it goes like this, right? -1 for the slope, down 1 over 1, down 1, right 1, down 1, right 1, down 1, right 1, goes through the origin. So it's got a right end behavior, which is down, and a left end behavior, which is up. And maybe just, but the next one's positive x squared. We know what that looks like, right? It's a parabola, opens up. And so you can see that it's up on both sides, right end behavior. What you're going to find here in a minute is I'm going to teach you that you need to find the right end behavior first. You need to know that the right end behavior is down before you find the left end behavior. It will really be very, very nice for you to find this before you find this. So I will always be finding the right end behavior first and the left end behavior second. I know, everybody's, we read English sentences left or right, and so everybody, but you got to get used to it. You got to get used to doing right end behavior first, left end behavior second, because of what we're about to teach you. So keep that in mind, what I'm about to teach you. What is the leading term? Now remember back in a few lessons ago, I said that it would really come in handy if instead of foiling out all that crap to find the leading term, we could just do this. And we could find out that our leading term is x cubed. And if I do it here, right? So this was x times x times x, but this one was negative x times positive x times positive x. So this one's negative x cubed. Okay? So that's the first thing. I'll focus my attention on this. I don't think there was anything on the previous slide. I'm going to check. Nope. Okay. So the first thing I need to know is the end behavior. So remember how I said that we're always going to find the right end behavior first and the left end behavior second? Those of you ignoring me right now are going to get it backwards, and then you're going to make mistakes. So this is based on, remember how I abbreviated leading coefficient as LC? If the leading coefficient is positive, then the right end behavior is up. And if the left end behavior, or if the leading coefficient is negative, then the right end behavior is down. You can see in my example here that the leading coefficient in front of the x cubed term is a positive 1. So we know that the right end behavior for this question is up. Now, the reason you have to find the right end behavior first is because the left end behavior depends upon what you chose for the first one, depending upon the degree. If the degree is odd, then the left end behavior is opposite of the right end behavior. If even, then the left end behavior is the same. But if you don't know what the right end behavior is, then what are you going to say? Left end behavior is opposite or the same, but you don't know what the right one is. Find the right one first. Well, what do we have here? We have a degree which is odd, right? We have a 3, right? 3 is an odd number. So since the right is up, that means the left will be down. We are going to hold that end behavior in our back pocket and come back to that in a minute. What are the zeros of this polynomial? Maybe I should write that down somewhere. I should write for my left, my right. So my right end behavior was up. My left end behavior was down. Hold on to that fact, and now we're going to get our zeros. What are our zeros? Well, we got a 5. Yep, hits the x-axis at 5. We got a 1, hits the x-axis at 1, and a -2, hits it at -2. Now, attach end behavior arrows. To outside zeros. Outside zeros. Attach it to that outside zero on the right and that outside zero on the left. Now the next part is where we have to decide what goes on in between. This is where those multiplicities come into play. Remember when we made our chart and we said zeros and multiplicities, and we would say things like, oh, we've got -2, we got 1, we got 5. Odd multiplicities cut through, well, I can't even spell very well, that's horrible looking. Cut through the axis. Odd multiplicities cut through the axis. Even multiplicities, we're going to talk about that in a second. Even multiplicities actually do something different. They bounce off the axis. They ricochet off the axis. Now, 1, 1, 1, these are all odd multiplicities. So that means it's going to cut through, cut through, cut through. Now, I want you to notice something. I did not get super picky about how high the little hill went or how low the little valley went. I didn't, because I just want you to learn how to sketch these. We found the end behavior, we found the x-intercepts, we found the multiplicities, we drew the picture. So let's go to the next one and do the similar thing. Okay, so my leading coefficient equals -1. That tells me that my right end behavior is down. My degree is odd, which tells me that my left end behavior is opposite of the right. Since I know that's opposite, that's down, that means this one has to be up. zeros, multiplicities. Well, I've got 0, that occurs once, 3, that occurs once, -3, that occurs once. These are all odd multiplicities, so they will all cut through the axis. So we will have a 0 at 0, and at -3, and at +3. Now I attach my end behavior to the graph. Right end behavior goes down, left end behavior goes up. Since those are all odd, it's going to come down, go back up, come down. Because each one of those cuts through the x-axis. We still have not seen an example where it bounces off the axis yet. I'm sure it is coming to a theater near you soon. Okay, so leading term, x times x times x times x. What do I get when I multiply these things together? I get 1x to the 4th. Let's see here. Right hand behavior, leading coefficient equals +1, so right hand behavior is up. And left hand behavior, let's see, my degree is even, right? 4 is an even number, right? So that means my left is the same as the right. Hold on to that fact. Now we make our zeros and multiplicities chart. It doesn't have to be all, huge. I see 0 occurs one time, and 3 occurs one time, and -2 occurs one time, and 5 occurs one time. So now we know we've got 0, 3, -2, and 5. Attach your end behavior to the outermost zeros. And because these are all odd multiplicities, it does something like this. Cuts through the axis each time. Still haven't seen an example where we've bounced off the axis yet. I'm sure it's coming. So here we have -x times +x times +x times +x. That gets me -x to the 4th. So my leading coefficient is -1. That tells me that my right end behavior is down. And then my left end behavior, that's based upon the even degree of 4, right? Even degree of 4. So that tells me it's the same as the right, so that is down also. Now let's see, zeros and multiplicities. Looks like I've got 0 one time, -3 one time, 4 one time, and 2 one time. Okay, so they're all odds, right? All odds, so that means they all cut through the axis. So far, we still haven't seen one of them. Let's see, 0, -3, oops, +4, and +2. Let me make sure I take that one dot off. I don't want you to think that's part of the graph, because it's not. And then I attach my end behavior to the outermost zeros. Cuts through, cuts through, cuts through, cuts through. Now, I catch kids who make up zeros which are not true because they do something like this. Cuts through, cuts through, cuts through, cuts through, cuts through, cuts through. Well, they made up a whole bunch of zeros that aren't there. It only goes through the x-axis 4 times. Don't make up zeros which you know are not true. That's how you end up losing points. Let me see if this, oh, that slide is finished. On to the next slide. All right, multiplicities. We already discussed them, how they affect the graph. We know that the odd multiplicity goes through the x-axis. That's the one we practiced. It's the even ones that we haven't seen yet. They actually bounce off the axis, right? They create a bounce. So we know that at 1, right, because that's the 0. So if we were making a chart, zeros and multiplicities, we'd have a 1 that occurred twice. That's an even multiplicity. And when we have that even multiplicity, And so you can do those same things that you've talked about, how we have, if we found our leading term, I'll call it the LT for the leading term, that would be, remember, it's x minus 1 times x minus 1, so that would be x times x, or x squared. Well, you can see that the leading coefficient, LC, equals positive 1, so that's telling me that the right-hand behavior is up, right? But because it's an even degree, then I know that the left-hand behavior is the same as the right, and so it also has to be up. Well, look at that. That matches the picture that we have talked about over and over and over, right? But instead of cutting through the axis, it's coming down and it's bouncing off the axis. I am not drawing a very great picture of that. The next one over, I don't know why these say 0. Oh, they say equals zeros because they want you to find the zeros. Like if we were doing a chart, zeros, multiplicities, we see that -2 occurs, but it only occurs one time. You can see the exponent is a 1. So at -2, with a slope of 1, and this goes up to the right, down to the left. Remember, the leading coefficient, the LC, is a positive 1, so that tells me that the right-hand behavior is up. And the degree is an odd degree of 1, so that tells me that the left-hand behavior is down, which makes sense. It looks just like the picture up above. And so the last example they give me is based on the cubic function, right? You can see it's up on the right-hand behavior up, and left-hand behavior down. So the 0 is at 2. Right-hand behavior is up. Left-hand behavior is down. It cuts through the axis. Now, when we get to when we get to the third power, yes, it does look a little bit different than it does to the first power. I might say to you, oh, look, it cuts through the axis. This one also cuts through the axis, but it has a little bit of a curve to it. That is true. And the higher that exponent goes, the more the curve gets, the sharper it gets. But the biggest deal to me is, did you cut through the axis or did you bounce off the axis? So now we're getting into other examples, okay? So, leading term. Well, this is really like saying -x squared times x cubed. Now, did I write them all out and do it the old-fashioned way? No. Who in their right mind is going to do this? Why would you do this? This is a waste of time. Don't do this. Not when you can tell me that -x to the 5th is your leading term without doing that, because you're doing -x squared and x cubed. And then we can think about right-hand behavior, because the leading coefficient equals a -1, so that would be down. And my left-hand behavior, let's see here, I have an odd degree. An odd degree means opposite, so that means that this has to be up. And then, once again, let's make my table, my zeros and my multiplicities. We got a -1 that occurs twice, and a -4, which occurs 3 times. -1, -4. At the outermost zeros, I must attach my end behavior. Now, this is where one of those is going to be a bounce. And so I'm going to try to highlight it for you. We have an even multiplicity, so the bounce is occurring here. The bounce is occurring at -1. So it's literally bouncing off the axis, and then the other one is odd, so it cuts through the axis. Now, if you wanted to be super technical, which you do not have to be, but if you wanted to be super technical, you'd come up and you'd bounce, and then you would do that little slide through right there where it looks a little bit like there's a curve right there at -4. I'm not going to sit there and harp on you and say, oh, you didn't put the little curve in there. Okay, so as long as you cut through the axis, I'm not going to argue with you, even though there is a slight difference in those. If you see us graph them and give you a multiple choice with a graph, you might see that little curve in the middle. Okay, so how about this? We got x squared times x times x. And if you multiply those together, you get x to the 4th. My right-hand behavior, since I have a leading coefficient, which is +1, is up. My left-hand behavior, since we have an even degree, right? The even degree means that it is the same. My zeros and multiplicities, I've got 0, that occurs twice. 2 occurs once, -3 occurs once. Once again, if you don't know how I'm finding those zeros, go back to the videos where we talked about setting the factors equal to 0 and solving them. That's exactly what I'm doing, but now that we've done it a million times, or we've done it several, lots and lots of times, I don't want to beat it into the ground because I know that you're perfectly capable of finding those. 0, 2, -3. Now I put on my end behavior, up, up, and up. Just make sure they go out and not in, because we don't want to fail the vertical line test, okay? There is a bounce right here because of the even multiplicity. So it cuts through the axis, bounces off the axis, cuts through the axis. And there's the picture of what we have. Next slide. Factor the polynomial to find the zeros. Okay, so now they put it in standard form. They want me to do the factoring. This is what we talked about doing earlier. Y equals, looks like there's a GCF on this of x cubed. So I'm going to pull an x cubed out of each one of those, giving me x squared minus 6x plus 9. But then we can see that we can continue to factor this into x minus 3 and x minus 3. We already know the leading term was x to the 5th because we had that at the very beginning. We didn't have to multiply anything together. They gave that to us. Now we know our right-hand behavior, right? Right-hand behavior because the leading coefficient equals +1, so that's up. We know our left-hand behavior because of the odd degree, right? Odd means opposite. So you got to know what the right-hand behavior is before you can tell me the left-hand behavior. My chart of zeros and multiplicities. I know that the first one is my 0, and it occurs 3 times. And then I have a 3 for the next one, which occurs 1 time. And, oh, wait a second. That's not 1 time, that's 2 times. Because x minus 3 occurs twice. And yes, we're going to have a bounce right here because of the even multiplicity. So let's see here. We've got 0 and 3. Attach my end behavior up on the right, down on the left. The bounce happens at 3, so boom, boom, something like that. Yes, I know that if you really wanted to be technical, you would do that little swoop-de-doop thing. You're coming down here and you would do that little swoop-de-doop thing right through there instead of being looking like it's going straight through. But it still cuts through the axis, and that's the important part, at least to me. Okay, so continuing on, we've got y equals, I am going to pull out a negative x squared out of this. So if I pull a negative x squared out, that leaves me with positive x squared and a minus 16. Folks, if you don't understand what I'm doing, I'm dividing each one of those. I don't know if I can zoom in enough, but I'm literally coming through here and dividing each one of those by negative x squared. And that's why the second term turns into a negative. So I now can see that I have a difference of perfect squares. Square root, one's a plus, one's a minus. Leading term, well, that's easy, negative x to the fourth. Right-hand behavior, because my leading coefficient is a -1. Okay, well, that's down, right? And then left-hand behavior, because I have an even degree, that must be the same. Zeros and multiplicities? Well, let's see. The first one is 0, right? When you set that equal to 0 and solve, divide by -1, take a square root. And that occurs twice. The next one, that's a 4. And that occurs once. And the last one is a -4, which occurs once. So 4, 0, -4. And the right side is down. The left side is down. There's a bounce right here because of the even multiplicity. So we're coming up, bouncing, and coming down. Something like that. Remember, I am not sitting there picking how high does that hill go? Did he go high enough? Did she go high enough? No, we're not doing that. We want to know zeros. We want to know end behavior. We want to know, is it bouncing or does it cut through the axis? Those are the important things to us. And that's it for these notes, I believe.